Okay, welcome back to the exciting world of mathematical induction. Hopefully, you have seen the domino analogy that is also posted on our website as far as how we set up mathematical induction because I will be referring to the domino analogy as we go through this problem. So here is the proposal on this problem. We've been studying this sequence of numbers where this I would refer to as our term generator. For instance, if n is 1, I get 8 times 1, 8 minus 5, 3, I get 3. And if n is 2, I get 16 minus 5, 11. So that's what generates our terms. And I've been studying this sequence, and it seems that every time I get a sum, the sum is equal to 4n times 4n minus 1. I'd love to be able to say that this works for all positive integers, but I don't have time to prove it for all positive integers, so I'm going to get the domino effect going. And as we spoke on the dominoes, the first thing we need to do is show that the first domino falls. That equates to this. We need to show the formula is true when n equals 1. That may be the easiest part of our job. When n equals 1, the left side of our equation just becomes the first term, 3. And of course, when n equals 1, the right side of the equation becomes 1 times 4 times 1 minus 1, or 1 times 4 minus 1, 3, or 3 equals 3, which in domino speak means, yes, the first domino is going to tip. And since we know that at least there is one domino that's going to tip, we may now assume a domino tips. The statement to assume a domino tips would have wouldn't be valid if I didn't know that one does tip. So I'm going to now assume the formula is true when n equals k. And this may be the toughest mindset to get through because, well, n, k, what's the difference? A big difference in our mindset on this. N refers to any positive integer, any domino in our list, and k just refers to one particular domino in the list. K is just saying, hey, there is a domino that falls out there somewhere. And if that is true, then this equation is true. 3 plus 11 plus 19 plus 27 plus dot, 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 plus 8k minus 5 is k times 4k minus 1. And you may say, well, that's exactly like our original equation, except k is in place of n. And visually, you'd be accurate, but mindset-wise, not so much. Again, the original equation is for any value of n, and we're hoping that's true. This is for a specific value k, a specific domino tips, and we can assume it's true because one of the dominoes tipped. So our goal is to show that if a domino tips, it leads to the next domino tipping. So our next step is to show the formula. There we are, we're back. Is true when n equals, what would it be? The next domino. The next domino after the kth domino, k plus 1. So our formula with k plus 1 dominoes in it becomes this monster. 3 plus 11 plus 19 plus 27 plus dot, dot, dot. And it's tempting to go right to my k plus first domino, but I'm going to revisit my kth domino. Plus 8k minus 5. Now my k plus first domino. 8 times k plus 1 minus 5 we want to show that that is equal to, put k plus 1 into the right side, and we get k plus 1 times 4 times k plus 1 minus 1. Quite a beast we have right there. And so all we have to do now is just algebraically simplify the left side and the right side and show they're equal. Oh, simplifying the right side is a bargain for any Algebra 1 student. Simplifying the left side, we've got a problem. I don't know how to simplify dot, dot, dot. What all lives inside of that dot, dot, dot. If only I could get that dot, dot, dot out of there. So this is where the ex-basketball coach in me comes into play. And I am thinking of this final equation here. The whole equation is a basketball game. And I am thinking of this equation right up here as my bench. And in this basketball game, what I don't like right now is our dot, dot, dots. And I notice one of my players on my team includes the dot, dot, dots. And that player is in this game. If only I had a player that played the same position to put in place of the player in the game. Well, down at the end of the bench, K times 4K minus 1's raising his hand, waving at me, saying, Coach, Coach, our dot, dot, dot point guard is in foul trouble. Put me in the game. So I can take, because K times 4K minus 1 is equal to my point guard, I can put K times 4K minus 1 into the game. So mathematically, or basketball speak, we would be saying that we're going to substitute. By substitution, in goes K times 4K minus 1, and takes the place of this whole guy right here. But my center's still in the game, plus 8 times K plus 1 minus 5 needs to be equal to K plus 1 times 4 times K plus 1 minus 1. Phew. Okay, you may want to get that last equation jotted down or take a look. When we flip to the next slide, we're going to pick it up from there. So we're back, and you get one line to not have to read through my messy writing. This is where we left off at the last step after our substitution. So now, simplifying this, we should be able to pass this off to a good freshman Algebra 1 student. A little distribution, 4k squared minus k, plus, here I would get 8k's plus 8, but minus 5 plus 3. Over here, I'll start my simplifying. K plus 1 times 4k's distribute plus 4, but minus 1 plus 3. And left side, 4k squareds. I've got a minus k and a plus 8k. That's plus 7k's plus 3. And a little old school foiling here. 4k squared plus 3k plus 4k plus 7k's. And a plus 3. Yay. So we wrap this up with the words, and we try to sound formal and highly intelligent here. By the principle, let's try that again. By the principle of mathematical be nice, see anybody can do this, mathematical induction, the formula is true. And that is mathematical induction from a domino perspective. All of our dominoes fall.